Most plants believe they have a predictive maintenance in place. What they actually have is a very expensive alarm clock. Here is how I know. Ask any plant manager, how do you predict failures? The answer is almost always the same. We set threshold. When vibration crosses 7.5 mm per second, the alert fires. That is not prediction, that is reaction with a very short delay. Real prediction does three things a threshold cannot. First, it recognizes the failure mode signature before any threshold is crossed. Second, it calculates how much time you have, not just something is wrong, 18 to 22 days remaining. Third, it tells you what is failing, not just vibration is high, drive and bearing, fatigue spelling beginning on outer race. A threshold tells you a number crossed a line. A predictive model tells you what is happening inside the asset and how long before it can become your problem. On line 3 at Vardhan, the bearing failure was detected on the ninth day. Vibration 11.7 mm per second, confidence 91%, threshold was 7.5 mm per second. A threshold only system would have fired at 7.6 mm per second. That happened on day 4. Rajan gets the alert, walks to the motor, puts his hand on the housing, feels nothing unusual. Current signature shows nothing. Team investigates, finds nothing. Files it under false alarm. Program loses trust before it has earned any. The predictive model on day 4 saw 8.1 mm per second above threshold, but only one technology was confirming it. Pattern did not match a known failure signature. So it said, watch, not pre-alarm. By day 9, the harmonic at the drive and bearing frequency was fully confirmed. Pattern matched, confidence 91%. The model knew that it was failing, not just that something was elevated. That is prediction. Threshold alert at day 4, team investigates, finds nothing, trust damage. Prediction alert at day 9, bearing failure, drive and 18 to 22 days RUL, work order raised, parts ordered, window day 12, rupees 8,200 replacement, zero emergency downtime. Same asset, same data, completely different outcomes. Every time something was unexpected at Vardhan, it cost rupees 16 lakhs. The same failure planned cost rupees 8,200. That is 19x the difference. When I ask plant what changed most after going predictive, the answer is never the technology. It is always the same thing. We stopped being surprised. A failure you predicted and planned for is not a failure. It is a scheduled intervention. Rajan had walked past the motor every day for 11 years. The model found something wrong in 11 days. A subtle thermal pattern on the motor end cap. Temperature 3 to 4 degree above normal. No threshold crossed, no alert triggered, but pattern matched something in a failure mode library. Insulation degradation, early stage. Rajan looked at the screen and then he looked at me. We always called that normal warning. We never thought it was a pattern. It was a pattern. 3 components made it visible. That is what this lecture covers. Before you build a prediction model, you document every known failure mode for that asset, not generic failure mode from a textbook. This asset, this line, this plant. For line 3 motor at Vardhan, bearing failure, drive and non-drive and motor imbalance, insulation degradation, coupling wear. Each failure mode has a signature, a pattern in vibration, temperature, current and acoustic that appears before the failure occurs. Bearing failure signature, harmonic at bearing pass frequency in vibration data. Confirmed by current signature harmonic at same frequency. Temperature rise at bearing housing 3 to 5 degree above baseline. The insulation degradation signature. Thermal pattern on the end cap. Slightly elevated, not threshold crossing. Stable but persistent over days. The library is the foundation. If a failure mode is not in the library, the model cannot recognize it. The model Learns from failure history. Requirement 3 to 5 documented failures events per failure model. Minimum. This is exactly why asset selection scorecard matters. Data availability score of 5 meant 3 years of historian data, 4 documented failures, all captured in CMMS with proper failure code. Line 3 motor had 3 previous failure of bearings, all documented. The model trained on those patterns. That is how it recognized harmonic on day 7 when confidence was 79%. If failure mode has 0 documented event, the model cannot predict it. You can still monitor for it, you cannot predict it. Remaining useful life is not a guess. It is calculated from 3 inputs. Current degradation rate, how fast signature is changing right now. Historical degradation pattern, how fast the same failure mode progressed in previous documented failure on similar asset. Operating condition, current load, temperature, environment. When line 3 showed 11.7 mm per second with a confirmed harmonic, the RUL engine compared that degradation rate at 3 previous bearing failures in historian. All 3 followed similar progression curve. The range 18 to 22 day. Not because of the number, because of the rate of change compared to what had happened before. The insulation degradation Rajan dismissed as normal warning went into watch status, not pre-alarm. 6 weeks later, temperature climbed 2 more degrees, pattern strengthening, confidence rising, the work order raised, motor inspected during planned window. Insulation resistance test confirmed early degradation, motor rebound, rupees 2.3 lakhs, planned cost. If caught at failure, full motor replacement 9.8 lakhs, emergency fret 22 hours downtime. The model saw that 11 years of human round had missed, not because Rajan was not doing his job, because the pattern was too slow and too subtle for an inspection round to catch it. The model only finds that what it has been taught to see. The most expensive word in manufacturing is unexpected. Unexpected failure, unexpected downtime, unexpected cost. Every time something unexpected happened at Vardhan, it cost them 16 lakhs. The same failure pattern cost around 8,200. That is 19x the difference. Remaining useful life removes the word unexpected from your maintenance vocabulary. Not because the model is perfect, because a range of 18 to 20 days gives you something panic never does. RUL is not a date, it is a range. 18 to 22 days means under current operating condition we are confident failure will occur in this window. The word current matters. If production load increases, RUL shortens. If load decreases, RUL lengthens. The maintenance planner does not schedule replacement for day 22. He schedules it for day 14 inside the window with the buffer. Standard parts on the standard fret, planned downtime window 40 minutes, line backup before next shift. RUL converts emergency cost into planned cost every single time. In 18 months, Vardhan Predictive Twin issued 31 RUL estimates across all monitored assets. 29 of 31 failure occurred within the predicted window. 2 occurred earlier than predicted. Both happened on days where production load had been pushed significantly beyond normal operating parameter. Not model failure. Operating condition changes that maintenance and operation had not communicated to each other. The fix was not technical, it was a 15-minute weekly meeting between maintenance and production to share the load schedule changes. After that meeting became standard, every RUL estimate was acted on the right buffer. The plant head asked me once, what is one number I should look at every Monday morning? I said lowest RUL across all monitored assets. Not the health score, not the alert counts, the lowest RUL, because that number tells him exactly how much time he has before the next intervention is required and whether the plan is already in place. He has looked at that number every Monday morning since months. Not once has it surprised him. RUL does not predict the future, it eliminates surprises.
If you want the complete framework, the full system, it's in my structured Udemy course. From first principles to live case studies. Link is in the description below. If this helped, like, share and subscribe to Reventis. Plant Intelligence Delivered. See you next time.